So positive correlation. Positive slope. I'm going to get you. Shut it. What that means as x increases, y increases. So you notice that they both increase. Negative correlation.
Let me get this. As x increases, y increases.
Negative slope. And as x increases, as y increases, as x increases, y decreases, yes.
Can it be the other way too?
You couldn't be a negative correlation.
But typically we have x, we start with 0, and we go to some larger number here. So we notice that as time goes on, the x is increasing. Okay. No correlation means that there's no visible relationship between the variables.
No, you had to be over here to understand it.
Oh, I get it.
All right, so we have
This one's positive.
5 graphs. A, B, C, D, and E. So which ones represent a positive correlation?
A,
D.
Oh, I'm sorry.
A, D. Okay, so A is positive, D is positive.
And then negative is B and C.
All right, A and D are positive, but what do you notice that's different about them? They both have a positive correlation, but what's
One's more
different?
scattered than
D is a little, like, more varied.
Annie?
It's just more spread out.
Okay. The points on A are closer together. The points on D are a little bit more spread out. So we label this one as a high positive correlation. And this one, because it doesn't have as tight of a relationship, we label this a low positive correlation.
But if you made the graph smaller, they'd be closer together.
Okay.
It's true.
It's still be spread out unless
Yeah.
you change the numbers.
All right, so which ones represent a negative correlation?
B and C.
B and C.
Okay, so we have negative correlation.
The C is high correlation. High.
No, it would be low.
Yeah.
And then the B would be
B would be low.
Why would B be low?
Because it's
Spread
spread out.
It's more spread out.
Oh, I thought it was
Goodness.
like low. No, Chelsea just said.
Way to use your brain there.
I did actually.
I get what you
So C is
Eyes.
high.
Yes.
Right, I understand what you're saying.
Oh, I
But what we're looking at is the relationship between the points there.
Oh.
Because they're closer together, they have a high correlation. All right, in E.
No correlation.
No
There is no
correlation.
If you look at it, never mind.
If you look at it, there's a bunch of dots
Kind
all
of looks like
over.
a frog.
Unless they kind of does. Like, see, like right
Like
there.
the eye and then another eye and then it has the mouth. That's a frog's face right there.
I
see a fish.
What do you
know how
see?
warm up kind of looks like Australia?
Like a blender where you got the bowl in
No, no. Not in the snow. Not in
All right,
the
thank you, Connor. All right, on the back, we have 2 more. F and
Positive and negative.
so F is
High
positive.
Would that be like super positive?
Super positive.
Well, they're like in a perfectly straight line, and that would be
They're in a
super
perfectly straight line, so that makes it
Super
perfect.
positive.
A perfect
I'll put a
positive.
super. Super.
You should put that on a test just to mess you up.
Super.
I guess it's gonna be right.
Super negative.
And And so this one's a perfect negative. All right, so
I take
careful, yeah.
I do that all the time.
All right, last week we were putting data into our calculator,
I was all over my head.
and we wanted to know what the equation was. So we arrowed over to calc, and then we looked at the ax plus b, hit the 4, hit enter, and it gave us a bunch of data. And then some of you saw this r come up. And I had just briefly said it's an indication of a statistic. So that's what we call Pearson's correlation coefficient.
Wow.
The R value. So we're going to refer to it as our R value. And it's a statistic,
It's not.
yes it is, that measures the linear relationship. So, R value for a perfect positive is 1. So what you would write is R equals 1 when you're asked the R value, if it's a perfect positive.
So if a negative, would that be negative 1?
R value for a perfect negative is Chelsea's
Negative.
negative 1. So you would say R equals negative 1 next to the graph.
See, I was right with some negative stuff in there.
This is
All right, now R value for
Is 0.
no correlation is
0.
0. So what's the range of values?
0.
Negative 1 to 1.
Very nice.
Jeez.
All right, so if they're not perfect, R value for a high correlation would be close to 1, but it wouldn't be exactly 1. Positive correlation, sorry, high positive correlation. Positive correlation gives us an R value of 1. So, for example, if we're looking at this one right here, we might say, we don't have the statistics, the exact points to determine what it is, but we could say that the R value would be close to 0.83, for example.
How do you come up with that?
It's just a random number that I came up with. On this equation, where we put the data in ourselves, the R value is 0.988. So looking at the graph, it's a fairly straight line, but it's not a perfect correlation, perfect positive correlation, but it is a fairly high correlation, and the R value for that is 0.98. This one doesn't have as perfect of a correlation, so it's not going to be 0.9, it'd be closer to 0.8 or 0.7 probably. So R value for high negative correlation would be close to what?
-1.
Negative 1. For example, you might see something like negative 0.75. That would be an example.
No, you're not. I feel like if you wanted to, you could.